Okay, here we go. Unit 5 of our SparkNotes for the first semester. So, Unit 5 is where we started talking about just all of our different types of fractions that we see, how we add, how we subtract, how we compare, and how we order those fractions, and then how we convert between a fraction and a decimal. So, our first 3 fractions over here are just for us to remember all the things that we know about fractions, what they're called, what their properties are. So, this fraction right here, the first one, we would read it as 5/8. And some things that I noticed is that it has a smaller numerator and a bigger denominator. So when I have a smaller numerator, a bigger denominator, this is what we call a proper fraction. So all proper fractions are less than 1. They're smaller than 1 whole. So this next fraction, 9/4, I notice it has a bigger numerator and a smaller denominator. So the opposite of the one we just had. So this is an improper fraction. All improper fractions are going to be greater than 1 whole. They have a secret whole hidden somewhere in here. And then our last fraction, I see that I have a whole number. Let's write it right here. A whole number. And then for the fractional part, I see that's a smaller numerator, bigger denominator, which means it's a whole number plus a proper fraction. This is what we call a mixed number. So mixed numbers are also always going to be greater than 1. So we started simplifying fractions, talking about how do we take a fraction and make it simpler to find the smallest equivalent fraction possible. So when I do this, I'm looking for a factor that the numerator and the denominator have in common. So for example, 8 and 10 both have the factor 2 in common. So if I divide them both by 2, 8 divided by 2 would give me 4. 10 divided by 2 would give me 5. And 4/5 is as simple as I can make it. This is as simplified as this fraction will get. 21/77, they both have the factor 7 in common. So 21 divided by 7 would give me 3. 77 divided by 7 would give me 11. 3 and 11 are both prime numbers, so this is as simple as it's going to get. 54/63 both have the factor 9 in common. So 54 divided by 9 gives me 6. 63 divided by 9 gives me 7. 6 is a composite number, but 7 is a prime number. So this is as simple as it's going to get. And then last but not least, 15/60, they both have the factor 5 in common. 15 divided by 5 would give me 3. 60 divided by 5, would give me 12. Now, 3 is a prime number, 12 is a composite number, but 3 is a factor of 12. So I can divide this one again, both by 3. So 3 divided by 3 would give me 1. 12 divided by 3 would give me 4. So 1/4 is as simple as it can get. So remember, when we simplify fractions, sometimes we get it as small as we can on the first try. Sometimes we can simplify it more than once to get it as small as possible. So we started talking about how do we add and subtract fractions, especially those that have unlike denominators. Their denominators are different. So the very first thing that we have to do when we see a problem that looks like this, 1/6 plus 3/4, is because those denominators are not the same, we want to try and find the least common multiple of those denominators. So what's the smallest multiple that they have in common? Sometimes you'll see this called the LCD, or the least common denominator, but those two are the same things. So when I look at 6 and 4, I know that the multiples of 6 are 6, 12, 18. The multiples of 4 are 4, 8, 12. So the smallest one that they have in common would be 12. So that's going to be my least common multiple, my least common denominator. So now that I know that the least common denominator is 12, I need to make those equivalent fractions that have that denominator of 12. So in order to do that, 6 times 2 is going to give me the 12. So whatever I do to the bottom, I have to do to the top. So 1/6 is going to become 2/12. My multiplier to get to 12 from 4 is times 3. Again, what I do to the bottom, I have to do to the top. So 3 times 3 would give me 9/12. So I made my equivalent fractions. They now have a common denominator. So now I can add or subtract, but this problem is adding. So I only want to add or subtract the numerators. That's it. My denominator is always going to stay the same. So 2 plus 9 would give me 11. And again, my denominator stays the same, so 12. And then I want to check and make sure that my answer is in simplest form, meaning can I simplify it at all? Well, 11 is a prime number and it's not a factor of 12, so this is as simple as it's going to get, 11 twelfths. So let's do a few practice problems. I have 5 6 plus 1 12th. The least common multiple of these numbers is actually the number 12. It's always nice when one of your denominators fits into the other one. So in order to do that, that would be 6 times 2. So what I do to the bottom, I have to do to the top. So 5 times 2 is 10. Oops. 2 times 6 is 12. Plus 1 12th, I don't have to change that one. Again, I'm going to add the numerators only. So 10 plus 1 is 11. And my denominator stays the same. So we get 11 twelfths. And it's the same thing when I subtract. So I need to find the least common multiple. The least common multiple of 10 and 4 is going to be the number 20. So in order to do that, that's going to be 10 times 2. So 7 times 2 would give me 14 20ths for the equivalent fraction. 4 times 5 will get me to 20. So 1 times 5 would give me 5 20ths for the equivalent fraction. So again, I'm just subtracting the numerators only. So 14 minus 5 would give me 9 20ths. 9 is a composite number and 20 is a composite number, but they don't have any factors in common. So this is as simple as it is going to get. All right, let's flip the page here. And now let's look at, well, what happens if I have to regroup when I subtract? So here's what's going to happen. Whenever I see a mixed number, because that's where we're going to see regrouping happen, I always want to start with the fractional parts first. And we're going to follow all the same steps that we just did. So my fractional parts are 1/6 and 1/2. I still need to find their least common denominator. So the least common denominator for 6 and 2 is actually just going to be the number 6. So I get to leave the 1/6 alone, but that 1/2, I've got to multiply both numerator and denominator by 3 to get that equivalent fraction of 3/6. Now, if I was just going to subtract, I would go, okay, 1 minus 3, and I can't do 1 minus 3. I don't have enough to take from here. So this is where the regrouping part comes in handy. So what I have to do is I have to take a whole fraction away from the whole number. So that means instead of my whole number being 5, it's going to turn to a 4 because I'm going to pull out one whole amount, or 6/6. And then I'm going to add that to the fractional part. So 6 plus 1 would give me 7/6 minus 3/6. And now I can do this subtraction problem. 7 minus 3 would give me 4/6. I can simplify. They both are divisible by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. So I know that the fractional part is 2/3, but then I still have to go back and subtract the whole numbers. So 4 minus 2 would give me 2. So my final answer here is 2 2/3. Looking at our next one, 7 2/9 minus 5 1/3. Again, need common denominators first, but I have a common denominator of 9. So 3 times 3 is going to give me 9. So my equivalent fraction would be 3/9. I can't do 2 minus 3, so I have to go regroup. So I'm going to pull a whole fraction away from the 7. So my 7 becomes a 6. I'm going to add 9/9 to it. So this will become 11/9 minus 3/9. Subtract the numerators only. So 11 minus 3 gives me 8/9. That is as simple as it gets for that. 6 minus 5 gives me 1. So I get a final answer of 1 8/9. Our next one, I have 4 1/5 minus 3 3/5. And lucky for us, we already have common denominators, which is fantastic. So I just need to say, okay, I can't do 1 minus 3. So I'm going to borrow. I'm going to regroup. My 4 is going to become a 3. I'm going to write this down here. I'm going to add a 5/5, a whole amount, to that 1/5. So it becomes 6/5 minus 3/5. 6 minus 3 gives me 3. My denominator stays the same. And then I need to subtract my whole numbers. That's 3 minus 3, which is 0. And since it would be weird if I wrote 0 3/5, I just get 3/5 for my final answer there. Next thing we did is we ordered fractions, so to put them in order from least to greatest or greatest to least. And we talked about there were a few options that you could do here, but the option that I pick almost every single time is to turn them into decimals. Because if I leave them in fraction forms to compare them, I got to give them all a common denominator. And when you're dealing with a lot of fractions like this, finding a common denominator can be a little difficult. So I'm going to build a table for me just to help keep myself organized. And the first thing I notice is that I have an improper fraction, 15/4. So I need to turn this into a mixed number just to kind of make it a little bit easier to see. So I know that 4 goes into 15 a total of 3 times. If I do that, 4 times 3 is 12, and 15 minus 12 would give me 3 pieces left over. So this is 3 3/4. So as a decimal, this would be 3 75/100. I'm going to do 13/8 as well. So 8 will go into 13 one time. That would give me 5 pieces left over. So this is 1 5/8. So as a decimal, this would be 1.625 or 1 625 thousandths. Now, this already here is a mixed number, but I don't know my ninths as a decimal, but I do notice that I can simplify 3/9. They're both divisible by 3, so it becomes 1/3. So 1/3 as a decimal is that funky one where it's 3, 3, 3, 3 with our infinity hat. It's repeating. And then 18/6. Well, 6 goes into 18 and even 3 times. So that's it. That's all I need. So now when I put these in order from least to greatest, I'm going to use the decimals to help me do that. So I see the smallest decimal is 1 625 thousandths. But when I write it, I've got to put it back in original form, which means I'm going to write it as 13/8. That's the smallest fraction that I see. And then I cross it off to help me know that I've already used it. The next smallest decimal I see is 3, which in original form was 18/6. The next one I see is 3 75/100, which is 15/4. And then I have, last but not least, 5 3/9 for my largest. Okay, I'm going to skip the next one just for time. Now we're going to talk about going from fractions to decimals. So there are 4 things that I want you to ask yourself. The first thing you ask yourself is it a benchmark? Is it one that I know off the top of my head? If it's not a benchmark, ask yourself, can it be simplified? Can I simplify it to a benchmark fraction? If that doesn't work, ask yourself, can you convert your denominator to 10 or 100? And if all 3 of those options fail, just divide, put the top dog in the house. Numerator goes inside. So when I see 3/8, 3/8 is a benchmark. We have 3/8, 0.375 or 375 thousandths. So that's why if I know my benchmarks, that's easy peasy lemon squeezy. I just know it off the top of my head. But when I look at 7/20ths, 20ths are not a benchmark for us. We don't know those off the top of our head. I can't simplify it because 7 is a prime number and it's not a factor of 20, but I can convert this denominator, find an equivalent fraction of 10 or 100. Now, I'm going to pick 100, and here's why. If I picked 10, my scale factor would be 20 divided by 2 would give me 10. And remember, whatever I do on the bottom, I also have to do on the top. And 7, if I divide it by 2, I'm going to get a decimal, and I don't want a decimal in a fraction. So I'm going to pick 100 because I know my scale factor here would be times 5. And again, what I do to the bottom, I do to the top. So 7 times 5 would give me 35. So this is 35 hundredths or 35 hundredths, 0.35. And then our last one, a decimal to a fraction. Our song that we sing goes, say it, write it, simplify it, which means I want you to say the decimal out loud. So this is 32 hundredths. You're going to write it in fraction form. So 32 hundredths. And then you're going to look to see, can you simplify it? So I know 32 and 100 are both divisible by 4. I'm going to not give myself enough room. 32 divided by 4 would give me 8. 100 divided by 4 would give me 25. These are both composite numbers, but they don't have any factors in common, so this is as simple as it's going to get. All right, moving on to Unit 6. Unit 6 is now where we started talking about multiplying fractions, dividing fractions. And I'm going to tell you, Unit 6 was probably our biggest unit that we did. It was our longest unit, so this is going to be the longest part of the video. So feel free to skip through to where you need to be for help. But here we go. So we sang our song and we started with multiplying fractions. And our song went, multiplying fractions ain't no problem. It's the top times the top and the bottom times the bottom, which means we're taking the numerator times the numerator and the denominator times the denominator. Now, it's important to remember that when we multiply, like if we see a whole number like this, a whole number doesn't have a top and a bottom already there. It doesn't have a numerator and a denominator. But we can fix that because every whole number is just going to get a denominator of 1. So when I see a problem that looks like this, 2/5 times 3, I can rewrite this to give that whole number a bottom. So 2/5 times 3 over 1. And now I've got that top times the top and the bottom times the bottom. So here we go. I have 2 times 3 would give me 6. 5 times 1 would give me 5. But this right now is an improper fraction, and I cannot leave it that way. So I've got to change it to a mixed number. 5 would go into 6 a total of 1 time. I get 1 piece out of 5 left over. So my final answer is 1 1/5. Now for our next problem here, these are called mixed numbers, remember? And our song doesn't go, I take the whole number times the whole number, the top times the top, and the bottom times the bottom. That's a lot to say there. All I need is the top times the top and the bottom times the bottom. But I can't ignore the whole number. They're there for a reason. So I need to take this mixed number and turn it into an improper fraction. And I do that using the 6/5 two-step. So remember, the text is two-step. I'm going to start by multiplying the denominator and the whole number. So 5 times 4 would give me 20. And then I'm going to add the numerator to it. So 20 plus 2 would give me 22. And my denominator stays the same. I'm going to do the same thing for 2 1/4. So 4 times 2 would give me 8, plus 1 more would give me 9 over 4. Now, I could just straight up multiply the top times the top and the bottom times the bottom. But remember, we learned that Smith super secret math hack called cross simplifying, where we can look at the numbers that are across from each other and we can see, can we simplify them? Go ahead and make the numbers a little bit nicer. So 5 and 9 cannot be simplified, but 4 and 22 have the number 2 in common. So 22 divided by 2 would become 11. 4 divided by 2 would become 2. So now I can multiply the top times the top. 11 times 9 would give me 99. And the bottom times the bottom, 5 times 2 would give me 10. Get an improper fraction. So 10 goes into 99 a total of 9 times. I would have 9 out of 10 pieces left over. So 9 9/10. Last one here, we've got 3/8 times 4/9. Nothing to change because they both have a top and a bottom. No whole numbers are involved, but I can cross simplify. 4 and 8 have the number 4 in common. So 4 divided by 4 becomes 1. 8 divided by 4 becomes 2. And I can cross simplify the other way as well. They both have 3 in common. So 3 divided by 3 would give me 1. 9 divided by 3 would give me 3. So now the top times the top, 1 times 1 is 1. Bottom times bottom, 2 times 3 is 6. It's already a proper fraction. It's as simple as it's going to get. So 1/6 is my final answer here. Then we started talking about the multiplication models. And there were 2 different types of models that we looked at, depending if it was a whole number times a fraction or if it was a fraction times a whole number. So let's start with the whole number times the fraction. This is where I told us to remember this is just like making copies. So you start with, for your whole number, how many copies did you make? So I made 1, 2, 3, 4, 5, 6 copies. And then I'm going to multiply that by what's shaded in each of those copies. So I'm going to cover up all of them except for one. And I see that 2/3 are shaded in. So this problem would be 6 times 2/3. Now our next one, I see again that I have 3 copies. I'm going to look at just one of them to figure out what is shaded in. And there's 1 piece out of 1, 2, 3, 4, 1, 2, 3, 4, 5. Goodness, I forgot how to count for a second. So that would be 3 times 1/5. But then our model kind of changes a bit when we start with the fraction. So when I have a fraction, like 3/4 times 2, when I look at this picture here, I already have my whole number of 2. Now, my denominator is going to represent the number of groups, the number of sections, the number of pieces, whatever you want to call it. I'm going to use pieces because it's easiest to write, but that's okay. And then my numerator is going to represent how many pieces that I want to circle. So here's what that means. When I look at this problem right here and I see 3/4, I'm going to start with the denominator because that's how many pieces I need to make. So I need to make 4 pieces out of 2 objects. So in order to do that, I'm just splitting each of the pieces in half. So now I have 1, 2, 3, 4 pieces. Each of those pieces then means that it is worth 1/2. But I only want to pay attention to 3 of those pieces. Just 3 of them. So if I pay attention to just 3 of them, that would be 1/2 plus 1/2 gives me 1 whole, plus 1 more half gives me 1. Oh my goodness gracious. Gives me 1 and 1/2. I'm switching to a pen. Okay, so if I do the same thing down here on this one, again, I'm going to pay attention to my denominator first. So I have 6. I need to make 6 pieces out of 3 objects. So again, that would just be splitting it in half, which means each of these is worth 1, or excuse me, is worth 1/2. And then since my numerator is 5, that means I'm going to circle 5 of those pieces. So this would be 1 whole, and 1/2 for an answer of 2 and 1/2. All right, then we started talking about dividing fractions. So our song went dividing fractions is easy as pie, just flip the second and multiply. So when we talked about flipping that second fraction, what we're doing is we're creating a reciprocal. So we said that word recip rhymes with flip. So a reciprocal is just a flipped fraction, that's it. So that means you are flipping the numerator and the denominator. So if I have 2/5, the reciprocal of that would be 5/2. I just switched where they were. So if I have a problem like 2 and 1/6, again, it's a whole number, so it needs a denominator of 1. So I'm going to leave the first number alone. I'm going to flip the second fraction. So instead of 1/6, I'm going to get 6/1. And then I'm going to change the division sign to be a multiplication sign. So I have 2 times 6 would give me 12. 1 times 1 gives me 1, which simply just gives me 12. I'm going to do 1/2 divided by 5. So again, I'm going to leave the first fraction alone. 5 gets a whole number of 1 as its denominator. So when I flip 5, it becomes 1/5. I'm going to change the sign to be multiplication. The top times the top gives me 1, and the bottom times the bottom gives me 10. And then our next one, I have 10 and 2/3 divided by 5 and 1/3. Again, since I've got mixed numbers here, I got to use the 6's to stay up. So I get 3 times 10, which is 30, plus 2 more, which is 32, over 3. 3 times 5 is 15, plus 1 more is 16, over 3. So again, I'm going to leave the first fraction alone. I'm going to flip the second fraction and change it to be multiplication. And thank goodness I see some cross simplifying can be done here. 3 and 3 have 3 in common, so those are both going to become a 1. And then 16 is actually a factor of 32. So it becomes 2 and 1. So the top times the top would give me 2, and the bottom times the bottom would give me 1 for a final answer of 2. Now, for our whole number and our fraction models, these worked a little bit differently. So what we're going to do is we're still going to start with that whole number, right? It's still just like making copies. So I have 4 fractions here, excuse me, 4 copies that I've made. And then I'm going to look at what have I broken up each of these pieces into. And I've broken them up into 3 pieces. So it's 4 divided by 1/3. And then I'm going to count how many pieces there now are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 divided by 1/3 would give me 12. On our next model, I have 2 pieces. I've divided them each into 1/3. So I have a total of 1, 2, 3, 4, 5, 6. So 2 divided by 1/3 would give me 6. Now for the next one, the fraction divided by the whole number. So when we do this, and on this type of model, we're going to start with the dark solid lines first. That's going to help us figure out how many pieces I have. So I have 1, 2, 3, 4, 5, 6. So my fraction is going to be 1/6. And I'm dividing it by, when I look at it, how many pieces I've broken up just one of them into. So I've taken that 6 and I've split it into 2 pieces. And when I do that, I'm going to look at just what one of those pieces is worth, which would be 1/12. This one right here, I'm going to start with the fraction that's on top. So this will be 1/4. How many pieces I've broken it up into, which would be 2 pieces. And then those pieces are each worth 1/8. Our very last one here, I have 2/5. I've broken it up into 4 pieces, and each of those pieces is worth 1/10. All right, then the last little bit that we did here, and I'm not going to do all of them on this page just because our video is getting kind of long, but then I was talking about word problems and how do we read word problems and figure out what operation is happening here. So when we're doing this, if the fractions are too much when you read a word problem, you got some options here. You can draw a picture or remove the fractions from the problem and replace it with the whole number. Sometimes those fractions just get in our way of being able to really see what is happening here. But by replacing them with whole numbers, that helps us figure out the operation. So when I look at this very first one here, and it says Dale has 4/5 of a tank of fuel in his car. He uses 1/10 of a tank each day. So I know how many days will it take for Dale to use the fuel in his car's tank. Now I'm going to be honest, I'm a really horrible artist, so I don't very often use the draw a picture. I like to use the second option more. So I'm going to get rid of the fractions here and replace them with whole numbers. I'm just going to say Dale has 10 gallons of fuel in his car, and he uses 2 gallons each day. So how many days will it take for him to use? Well, if he has a total of 10, he's using 2 every single day. That helps me know that I'm dividing. So I know that dividing is my operation here. So now I'm just going to put the fractions back. He has a total of 4/5 of a tank, and he's using 1/10 every single day. So his problem is going to be 4/5 divided by 1/10. So I've got my fractions, and I know dividing fractions is easy as pie. Just flip the second and multiply. So I know that 10 and 5 can be simplified. They both have 5 in common. So it would be 1 and 2. 4 times 2 gives me 8. 1 times 1 is 1. So it's going to take him 8 days to run out of gas. Okay, our next one here says Ziomara spent 3.5 hours on homework last weekend. If she spent 2/3 of, and I'm going to stop right there, that's really important. When I see a fraction next to the word of, that tells me that I am multiplying. So I know this is going to be 3.5 times 2/3. You know, multiplying fractions ain't no problem. It's the top times the top and the bottom times the bottom. So I need to do the Texas 2-step here. So 2 times 3 is 6, plus 1 more is 7. Halves times 2/3. I have 7 times 2, which is 14. 2 times 3, which is 6. 6 will go into 14 2 times. I would have 2 out of 6 pieces left over, which can be simplified to 1/3. So she spent 2 1/3 hours writing that. All right, last one, Unit 7, we made it. Unit 7 was what we did right before we left for the winter holidays, and it was all about expressions versus equations and how we solve those one-step equations. So we started by talking about what is a variable. So variables are just a letter that we use in math to represent an unknown number. So it could be like the letter X, the letter Y, the letter B, just something that's kind of plugging that hole of what we don't know. And then when we see them in equations, we know that we can look out for equations because an equation is going to have an equal sign, or if it's in word form, it's going to have the word is or gives. So let's just do a few examples here, trying to figure out if we have an expression or an equation. So y equals 2x. I see an equal sign. I know this is an equation. K divided by 4. I don't see the word is, I don't see the word gives or equals, so I know this is an expression. J minus 8. Again, there's no equal sign here, no is or gives, so this is an expression. The sum of 5 and b is 12. That word is tells me it is an equation. 24 is 6 more than x, equation. And just 7s, no equal sign, so that is an expression. So then we started solving for solving those variables, trying to figure out what is that missing piece, what is that what does that variable represent? So if it says given the equation x divided by 2 equals 4, find the value of x. I'm going to rewrite it just so I have some room here. Now, remember I told the story of you want to get rid of what is bothering x. So I'm going to build my t-chart. And right now I see that divided by 2 is what's bothering x. So I need to do the opposite to get rid of it. So the opposite of dividing by 2 would be multiplying by 2. What I do to one side, I have to do to the other side. My 2's are going to cancel out. So I get x equals 4 times 2, which would be 8. Our next one over here, our equation is x minus 1 equals 9. And I'm going to build my t-chart. What's bothering the x is this minus 1, so the opposite would be plus 1. What I do to one side, I do to the other side. So I get x equals 10. Our next equation is 3x equals 15. Building my t-chart. What's bothering the x right now is that times 3, so the opposite would be divided by 3. What I do to one side, I do to the other side. So I get x equals 5. Our next one is x plus 2 equals 5. Build my t-chart. What's bothering the x right now is plus 2, so the opposite would be minus 2. Do to one side what you do to the other side, and we get x equals 3. Our next one, 1/5 x equals 5. So we didn't like problems that look like this. So whenever we had a variable that had a fraction in front of it, as long as the fraction has a numerator of 1, we can fix and replace what's happening here. So instead of having 1/5 x, we can rewrite this as x over 5 equals 5. Build my t-chart. What's bothering the x is going to be divided by 5, so the opposite would be times 5. So we end up with x equals 25.